Hi, ladies and gentlemen. My name is Muhammad Adib bin Muhammad Noor Adnan, the first presenter for class BMMH. So today we're going to be talking about our mini project, which is torsional loading evolution for the screwdriver. So what is torsion? Torsion is the twisting of an object caused by a moment acting, which is subjected to torsional load, which is torque about its longitudinal axis. And a moment tends to cause twisting is called torque. Now, the purpose we are doing the project is to study the torsional loading from the screwdriver, and then to determine the free body diagram from the actual structure, to develop EOE for the force act on the structure, then to find the maximum torsional force that will fail the screwdriver, and lastly to determine the factor of safety in the screwdriver.
Assalamualaikum and hi. My name is Muhammad Aiman Haiqal bin Wira, and my metric number is B0919103667. Okay, now I would like to talk about our project, which is torsional loading evaluation of screwdriver. Okay, let's go to my first topic, structure. This is a picture of our actual structure, which is the screwdriver used to screw. Okay, from the actual structure, we can get the material properties of structure. We assume that our screwdriver made from steel. After the research, we get the yield strength, which is 370 megapascal, and Young modulus 207 gigapascal. Last but not least, the shear modulus, which is 78 gigapascal. Next, the dimension. The length of screwdriver that we measure is 35 mm. After we convert to the meter, we get the 0.035, and the diameter is 6 mm. As you know, if we want to get the radius, we need to divide by 2. Then we can get the radius. So the radius of this screwdriver is 3 mm. After that, we can get the polar moment, which is J, by using the formula pi over 2 times C power of 4. And then we get the value of J, which is 1.273 times 10 power of negative 10. Now, the maximum resultant internal torque is determined. So we can assume the maximum torque 3309.8 Newton. Then we convert to the kilonewton meter, and we get the 3.310 kilonewton meter. This is our free body diagram of screwdriver. You can see that the rotation of torque and the value of torque we know from the previous is 3 kilonewton, and the length is 35 millimeter. But we don't know the force, right? So by using the equation of moment, we can determine the maximum of force, which is 85.714 kilonewton. So this is the maximum force to break the tips of screwdriver.
Assalamualaikum and good afternoon. My name is Muhammad Akmal. My matrix number is B0919102114, and today I'm going to explain about factor of safety. Factor of safety, or also known as safety factor, is expressed as how much stronger a system is than is for an intended load, or in easier words, how much the load can it bear before failure. In our project, we calculate the safety of factor of screwdriver, which maximum force it can stand before failure. We can calculate the safety of factor by using this formula, which is ultimate stress over allowable stress, or yield stress over allowable stress, which is the same. Here, we have shear stress equal to 0.6, yield strength equal to 370 megapascal, where we can use to find shear yield strength. The result we get after the calculation is 222 megapascal for yield stress. To find factor of safety, we have to find the allowable stress first by using force over area formula, where force that we get before, which is 85.71 kilonewton, divided by the area, which is 0.006 times 0.07 meter square. Then we get the result, which is 20408 kilonewton per meter square. Then we convert to megapascal. After that, we can calculate the factor of safety by divided the yield stress by allowable stress. The result for factor of safety is 1.09. For discussion, as we know, torsion is twisting of an object caused by a moment acting or subjected to torsional load. In our project, we analyze the torque and force or torsional force to find the maximum torsional force that we feel the screwdriver. In order to find maximum torque, we are using this formula, which is tau equal to Tc over J, where we can denote that tau is max shear stress, T is torque, C is radius, and J is polar moment. All the data is given and we are able to find the torque. Next, to find maximum force, we using this formula in EOE, which is T plus F multiplied by L, where T is torque, F is force, and L is length. Then we are able to determine the maximum force for this material before it breaks. Then after getting the result, we already know what is the maximum torsional force this material can bear before failure. Meanwhile, the safety factor for this project shown that the material is safe in this working environment because the result is bigger than 1. That's all for me.
For the conclusion, we have managed to find the maximum torsional force for the screwdriver, which is 85.714 kilonewton, and the allowable stress is 204.1 megapascal. And basically, if the screwdriver working at 205 megapascal, it will break the screwdriver. And lastly, we also managed to find the factor of safety for the screwdriver, and the result, the material is safe to use for working environment. So that's all for us, and have a good day.